It's 2025. You're in a dim room, laptop humming, no engineering degree, no mentor, and your electronics knowledge could fit on a sticky note. You just watched a robot sort Skittles and thought, I want to do that. This is ground zero, the best place to start. The beauty of starting from nothing, every tiny win feels epic. The world of embedded systems looks like a secret club for geniuses, but here's the truth. Everyone started clueless. The journey from zero to building a wild project isn't a leap. It's a series of awkward, hilarious steps. Embrace being a beginner. Don't dig up ancient textbooks. Dive into YouTube tutorials. Find creators who make you laugh and explain things simply. Your goal isn't to understand everything, just soak in the language and excitement. You're building a mental map, even if it's just a "you are here" sticker in a sea of dragons. Forget expertise for now. Your job is to watch, absorb, and get hyped. You'll hear terms like voltage, current, and GPIO pins. Don't panic. Just let them wash over you. It's like learning characters in a new show. Confusing at first, but soon you'll know who's who. You're meeting the cast of your new favorite show, My Desk, The Electronics Saga. And trust me, it's about to get interesting. Here's the real secret. Learning this isn't about genius. It's about discipline. You don't need a 200 IQ or calculus skills. You need to show up even when you don't feel like it. Think of it like the gym. You start with the empty bar, do the reps, and slowly get stronger. Learning electronics is the same. Your brain is a muscle. The genius is just someone who did the boring reps when no one was watching. Discipline means forming a tiny, achievable habit. Spend 25 minutes a day tinkering. Set a timer, put your phone away, and for those minutes, you're an engineer. Even if you just Google what a resistor does, you've won the day. Consistency is your cheat code. This habit shields you from frustration, because there will be days when nothing works. You'll follow a tutorial, and your project will just sit there, mocking you. Most people quit here, mistaking a roadblock for failure. Not you. You have a system. Your goal isn't daily success. It's daily effort. The discipline of showing up will carry you through the valleys and onto the peaks. Progress is built on small, repeated actions. Don't burn out trying to do everything at once, so just keep showing up. That's how you win. That's the only cheat code you need. Now let's get practical. Time to get your hands dirty and spend a little money. Grab an Arduino Uno starter kit. It's the golden retriever of microcontrollers, friendly, forgiving, and supported by a massive community. The kit comes with everything: breadboard, jumper wires, LEDs, resistors, buttons, sensors, maybe a motor. Don't worry about what everything does yet, just get the kit. Once it arrives, your first challenge: install the Arduino IDE from the official website. Ignore scary computer warnings. Just install it. Plug in your Arduino with the USB cable. Tiny lights should turn on. Congrats! You've powered up your first board. In the IDE, select your board Arduino Uno and the correct port. If you see COM3 Arduino Uno, you're set. You're now ready to command your new robot brain. Let's make it do something. This is the rite of passage, blinking an LED. It sounds simple, but making a light blink on command is pure magic. Grab your breadboard, an LED, a resistor, and 2 jumper wires. Plug the LED's long leg into one row, short leg into another. Connect the resistor from the short leg to the blue ground line. Wire GND from Arduino to the breadboard's ground and pin 13 to the LED's long leg. Circuit built. Open the Arduino IDE, go to File Examples. Blink. The code is ready for you. Don't stress about understanding it all yet. It tells the Arduino turn pin 13 on. Wait, turn it off. Wait, repeat. Click Verify, then Upload. The board flashes and then blink. Your LED turns on and off every second. Stare at it. You did that. You're a sorcerer now. This tiny victory is the start of everything. Celebrate it. Now let's build your skills. You blinked the light. You felt the power. Now don't try to build a self-driving car. Most people get one win and aim too high, get frustrated, and quit. We're not doing that. We're building a foundation. For the next few weeks, do drills, not projects. Week 1, digital I/O. Blink LEDs in patterns, control multiple LEDs, use a button to turn an LED on and off. You're making your circuit react to the world. Week 2, analog and PWM. Use a potentiometer, a knob, to read values with analog input. Watch the numbers change in the serial monitor as you turn the knob. Learn PWM by fading an LED. Make it smoothly brighten and dim. Connect the knob to the LED's brightness for your first dimmer switch. These drills, digital I/O, analog I/O, PWM, serial communication, are the bedrock of embedded systems. Master them before moving on. Don't rush. Repetition builds confidence. Each small exercise is a step toward bigger projects. This is your training montage. Stick with it. The basics are your superpower. Once you're comfortable, you're ready for your first real project. Let's build something useful. Onward. You've done your drills. Now let's build a digital thermometer that displays room temperature on your computer. Grab a TMP36 temperature sensor. 3 legs, power, ground, and signal. Connect power to 5V, ground to GND, and signal to analog pin A0. That's the hardware. Done in seconds. In code, read the analog value from A0. It'll be a number from 0 to 1023. Convert that number to voltage, then to temperature using a simple formula. Google Arduino TMP36 tutorial for the math. Type out the code yourself. Don't just copy-paste. Open the serial monitor to see the temperature. If you get gibberish or wild numbers, don't panic. Debug check wiring, code, pin numbers, and those pesky semicolons. This is real engineering, solving problems, not just following instructions. When you finally see a real temperature, the victory is sweet. You didn't just follow a recipe, you solved a puzzle. That's what makes this fun. Every bug is a lesson. Every fix is a win. You're leveling up. Ready for the next challenge? Arduino's language is friendly, but if you want to get serious, it's time for C. Most pro-embedded systems use C. It's faster, more efficient, and gives you more control. Arduino code is just simplified C++ with libraries. Now you'll start thinking in C. This means learning about pointers, variables that hold memory addresses, and registers, tiny storage inside the microcontroller. Instead of, you'll write something like, directly flipping bits. It looks cryptic, but it's just fast, direct control. Don't try to learn all of C at once. Start by rewriting your Blink sketch using register manipulation. Learn bitwise operations and Oregon XOR NOT. This is a big step up, so be patient. Find C tutorials for microcontrollers and work through them slowly. This is what separates hobbyists from pros. You're taking off the training wheels. Welcome to the big leagues. You've earned a reward. Let's go wireless. Making things talk through thin air is pure magic and opens up endless project ideas. Start simple. Make a remote-controlled LED using 433 MHz RF modules. One Arduino with a transmitter, another with a receiver. Press a button on the first, and the second lights an LED. Use a library like Radiohead or VirtualWire for easy coding. On the transmitter, read the button and send a message. On the receiver, listen for the message and turn on the LED. Debugging is part of the process. Check wiring, power, and add antennas if needed. Play with range and try sending different messages. The first time you press a button and see a light blink across the room, you'll feel like Tesla. You've conquered the invisible world of radio waves. Wireless projects boost your confidence. Now you're unstoppable. Let's unlock the next skill. Every engineer faces the datasheet, a dense technical manual for components. It looks intimidating, but learning to read datasheets is empowering. Tutorials are great, but for obscure parts, the datasheet is your only guide. Start with something familiar like the TMP36 sensor. Find the pinout diagram shows which pin is power, ground, signal. Check the absolute maximum ratings, don't exceed these or you'll fry the part. Look for electrical characteristics. This is where you find formulas and key specs. Don't read it cover to cover. Treat it as a reference practice. Pick a component. Find the pinout max ratings and key formula. This skill unlocks any component, not just the popular ones. With practice, datasheets become less scary. You're now truly independent. The world of electronics is wide open. You started with nothing. Now you're building, debugging, and even reading data sheets. You're no longer a beginner. You're a maker. The final step? Share your work. Don't worry if your project isn't perfect. Sharing is about community and learning. Start a blog, YouTube channel, or Instagram for your projects. Document your journey, especially the failures. People connect with progress, not perfection. Explaining your work helps you understand it better. Teaching is a powerful learning tool. Post your code, ask for feedback, comment on others' projects. The maker community is supportive and inspiring. Your story could spark someone else's journey. A public portfolio is more valuable than a perfect resume. Show the world your creations, messy, brilliant, and real. Celebrate your progress, keep building, keep sharing. And if you build a squirrel obstacle course, send me the link.